with Excel. So we did sports analytics. We started about week 13, so there was plenty of NFL data that we could mine, which was really cool. And then and you can see this on the videos, I made very clear, this is not for betting. I was like, I didn't want to encourage betting, but I wanted to tell them, you can make a lot of money doing this. That daily fantasy sports is a huge, $1 billion industry, right? Only 1.3% of the people that play fantasy sports actually, they make 91% of the profits. And I asked them, why do you think that is? You know, are they sports players? Are they just throwing darts? No, they're mining the data. And again, this is $1 billion industry. Now, we can look at the stock market, that's $1 trillion industry, right? And it's the same kind of techniques that you use for sports teams. So that was my deal. Is some of the students didn't really like American football. Some of them were into soccer. Most of my kids were Hispanic. That's a terrible sport to mine. So we did football, and I basically told them, think of these teams as maybe a company, and the points they give away would be debits, and the points they gain are profits. Same concept. The same things that we use to model a sports team would be the same kind of things you would use to model the stock price. And in football, the teams kind of made a really, when I started getting into this, what I realized is you can't treat a sports team the same, that there's an offense and a defense, right? That every, mark, how well the team does is, one side of the team tries to score as many points, and the other team tries to prevent the other team from scoring. So this is the basis of what we use to do the modeling for the NFL. And we just collected scores over the entire year. And you can see, here's our teams. This would be Arizona defense, offense. A lot of practice formatting. Obviously you don't want to just look at numbers, so we would color the boxes. They got extensive Excel experience. And here's what we would do is to figure out winners is we would basically just take the average of what a team scores, what they give away, and then whoever they were playing that way, we just took the average of what the offense and the opposing team's defense. And we could calculate this in many different ways. We just took an average ones. We talked about using medians in case you have outliers. So we tried the medians. We did a weighted average to try to put more emphasis on games that were played recently. So what I was showing them is, you can use this information, and there's lots and lots of different ways to model. And there's no way, I didn't want to tell them that one way was wrong. What I wanted to do is, let's figure out which way works best. And when we do this, and we talk about scores, now we're talking about distribution. And this is actually truly, this is real life math. That every time you measure something, it's not going to be the same measurement, right? That even if I weigh my own weight, every day it's going to fluctuate. And there's going to be a kind of a mean that's in the middle, and everything's going to be distributed on the sides. And so this gave us, it's just like the teams, is that, a team might score an average point, but the distribution of that, they're not going to score that every time, right? So it allowed me to bring in concepts like standard deviation. How big is this curve? You go out 2 standard deviations, now you have 95% confidence. So I would expect 95% of the data to fall here. What happens when it starts falling outside that confidence interval, right? So again, it's showing them that these numbers have form, and it's not, and most things in life are probability. Here's what I found fascinating. And I should have expected this, but teams play better either home or away, right? And it's statistically, some teams actually statistically play better, and it's not just the offense, but it can be, it could be the defense or alone or both teams. Do you think that all teams play better at home? No, they don't, which I thought was crazy. The Cowboys under Romo are actually, they do better away than they do actually at home. They score more points than you would expect, which is, I just thought that was nice. And then Raiders, they're terrible anyway. So. I had 2 Raiders fans in my class. It was horrible. And that gives us a chance to talk about t-test. How do I know that these things are different? How do I know that they play different? Is anybody familiar with the history of a t-test? All right, one person. So it actually developed in Guinness Brewery. And, it gave me a chance to talk about the guy that did this. This is William Gossett. This was the early 19th century. He was kind of slumming working for Guinness. Guinness wanted to know if they shipped their beer farther than 70 miles, if it would affect the taste of the beer. So what he would do is, you can measure all kinds of things of beer. So what he developed was, again, he knew that every time you measure something, it's not going to be the same. So he basically developed a test to determine whether two things are truly different. And then this gave us a chance. These hills, if you're comparing to the two different things, where they cross, you can pretty much think of that as your p-value, your probability. So that the lower they cross, the more likely they are to be different. Any math teachers in here? All right, good. Cool. Again, and then we can graph all this stuff. You can look at all the teams. This was a program called JUMP, and I'm going to talk about this a little bit. But, this is another program that we can use. So you have Excel, and our kind of next step up into this was using the JUMP program. It's a derivative of SAS. It's kind of the GUI version of SAS. I don't know if anybody's familiar with that. Pretty popular software. And then we would make our predictions, we would do the averages, and then if we didn't get what we thought we were, basically we were like, okay, what went wrong? And so that allowed us to kind of reanalyze our model. And then we would go in and look at, okay, this team scored 20 points less than they were expected to. Why was that? And so we'd actually go in and look at turnovers. Well, they had 3 turnovers and the other team had 0. Can we add that to our model? And so we look at turnover. So the 3 things in football that really affect the score that we found were turnovers, sacks, and what was it? Turnovers, sacks, and home and away. And so at the very end, we kind of had it dialed in. Yeah, go ahead.
Did you do anything with injuries, specific key players being out? Did that have anything to do with it?
We could, and that's when the model fell apart. That was a little too extensive, but we could totally have done that. Not only that, but if we knew a player was out and then the offense didn't score a certain amount of points, we could probably go, that person's probably worth this many points. Yeah, we could totally do that. There are so many ways to go with this if you teach this to students. And you don't have to do football. Anything has data, right? You can do this in an MBA. You can do it with anything. And so for 3 weeks, the green was the amount of games we got correct. The red was the ones we got incorrect. We were about 70% accurate with our the best model that we could use, which was just taking this straight up average of all the games. Weighing them had no effect, So yeah, we guessed 70% of the games, which is probably better than most of the, a lot of the experts that were around then. So, and when they saw this, they thought that was really cool. And that's what I wanted them to do, was see the pattern. Take this data. If you dive into the data on anything you're looking at, you're going to get more out of it. And at the end of this, they understood football. They would come in and tell me that, yeah, I was talking to my dad about football and I never did this before. And, and he was wondering how, I was getting all this information, just mining it. And as you can see that the level after the NFL section, pretty much most people increased by 2 levels of experience.
What did you use to test that?
What's that?
How did you?
That was self-reported.
Okay.
So they were definitely more confident with Excel, and sometimes that's all it takes, right? That I showed them it wasn't scary, and now they were, by the end of it, I would imagine most of them would have said they were expert, even though they probably wouldn't. And this is statistically significant, just to, for the math teacher back there. The P of 0.0003. So that's not very much of that, the hills crossing. So what did we learn from this section? It was Microsoft Excel, lots and lots of practice. Also, by modeling these teams, they learned the concepts of mean, median, standard deviation. And then basically, we could adjust the calculations to approximate reality. So basically modifying the model and looking at regression, and we could talk about confidence intervals. Again, all of these mathematical key concepts that we could introduce to these kids. And then seeing trends and seeing the difference in NFL teams, t-tests, p-values, standard distribution. It amazes me that almost no kids we're not teaching statistics at the high school level very much. And that's really what real life is. It isn't yes or no's, it's probabilities.
Well, it's probably not on the standardized test.
I guess not.
But calculus is, so most schools teach calculus even though you're probably not going to use it.
Exactly, so until we change that, you're not going to change schools.
Yeah. And then again, the analysis of the proposed models. Okay.